You hear about AI learning all the time, right? But what does that actually mean? What's going on under the hood? So today, we're going to climb what I like to call the learning ladder and break down the main ways machines actually master new skills. Let's get started. And this is really the big question, isn't it? When we say a machine learns, we're not talking about it just memorizing facts like you'd cram for a test. Oh no, it's way more dynamic, way more powerful than that. And it all boils down to one thing: data.
So, here's our game plan. We'll start with the basics of how machines learn, then we'll climb up the ladder. We'll look at learning with a teacher, then finding patterns all on its own, and even learning from good old trial and error. And finally, we'll get to the really cool stuff, the smarter, faster ways AI is learning today.
All right, let's start at the bottom rung. So how do machines learn? Well, the real revolution happened when we shifted away from the old way of doing things, where a programmer had to write out every single possible rule by hand. The new way? We let the machine figure out the patterns for itself. And that brings us to the core idea of machine learning. See, instead of a programmer writing endless if this, then that commands, we just feed the computer a ton of data. And we let it discover the important patterns and relationships all on its own. It's really about the machine inferring things, not just following instructions. Okay, time to climb up to the first major rung on our ladder. This is probably the most common type of machine learning you'll run into, and it's called supervised learning. Think of this one as learning with a teacher or a guide. So the key ingredient here, the secret sauce, is something called a labeled dataset. What does that mean? Well, imagine you give the machine 1,000,000 photos of cats, and every single one has a label that says cat. And you do the same with 1,000,000 photos of dogs, each labeled dog. The AI's job is to study all these examples and figure out the visual patterns that connect the picture to the right label. Yeah, the student-teacher analogy is just perfect for this. The labeled data is basically a giant answer key for our AI student. By going through thousands of problems where it already knows the right answer, it starts to generalize, and eventually, it can tackle brand new problems it's never seen before, just like a student taking a final exam.
And trust me, you see this stuff everywhere. That spam filter in your email, that's supervised learning. It was trained on tons of emails that humans already labeled as spam or not spam. Or, when a website guesses a house's price, or a bank decides on your credit score. Yep, those are models trained on historical data where all the outcomes were already known.
Okay, but what happens when there is no teacher, no answer key? Let's climb up to the next rung and find out. This is unsupervised learning, and it's where the machine is really left to its own devices.
With unsupervised learning, you basically just dump a massive, messy pile of raw, unlabeled data in front of the algorithm. You don't tell it what to look for. Its job is to dive into all that chaos and find the hidden structures, the natural clusters, and any weird outliers, all by itself. The detective analogy is just a brilliant way to picture this. The AI is the detective, and the unlabeled data, that's the messy crime scene. It has to sift through all the evidence, looking for clues, similarities, differences, to start grouping things together and build a theory about what's going on. And the whole time, nobody's there to tell it if it's hot or cold. And this is super useful, especially in business. You see, companies use it to sort customers into different groups based on their buying habits, which is huge for marketing. Banks use it to spot weird transactions that could be fraud, precisely because they don't fit any normal pattern. It's fantastic at finding that needle in a haystack. This slide really just boils it all down, doesn't it? It's the key difference. Supervised learning gets the input and the correct answer. Unsupervised learning only gets the input and has to figure everything else out. You could say one is all about prediction, while the other is all about discovery. All right, on to the next rung. And this is a totally different way of learning. It's not about data with labels or even finding hidden patterns. This is all about taking action. Welcome to reinforcement learning. And the best way to think about this is like the classic carrot and stick approach. It's like training a dog. The AI, which we call an agent, tries to complete a goal. If it makes a good move that gets it closer, it gets a reward. That's the carrot. If it makes a bad move, it gets a penalty, the stick. After millions and millions of tries, it starts to learn the best sequence of moves to get the most carrot. And this whole thing just works in a continuous loop. The agent takes an action, the environment gives it feedback, a reward or a penalty. And then the agent uses that feedback to tweak its strategy for the next try. It's just this constant cycle of trial, error, and getting better, all focused on one thing, racking up the highest possible score over the long haul.
This is the technique behind some of AI's most mind-blowing achievements.
It's how AI systems mastered ridiculously complex games like Go and chess, crushing the best human players on the planet. It's also being used to teach robots how to walk and get around in the real world, and it helps self-driving cars make split-second decisions on the road.
Okay, we've made it to the top of our ladder. This is where things get really interesting, where all these different learning styles start to mix and blend together to create the really powerful, efficient AI systems we see today.
Now this is seriously clever. Self-supervised learning takes a gigantic pile of unlabeled data, think like all the text on the internet, and it basically invents its own game. For instance, it might take a sentence, cover up one of the words, and then try to guess what word is missing. By doing that billions of times, it learns about so much more than just words. It learns grammar, context, meaning, all without a single human teacher.
And here's the big aha moment. This exact technique, self-supervised learning, is the engine that powers the huge language models we're all using now. It's what lets them understand and generate text on such an incredible scale. It's an absolute game changer.
And last but not least, we have transfer learning. And the basic idea here is, why start from scratch every single time? Think about it. Let's say you have a model that's already been trained to recognize all sorts of animals. It's already learned basic things like shapes, textures, edges. With transfer learning, we can take that knowledge, that head start, and quickly fine-tune it for a new, specific job, like telling the difference between dog breeds. It makes building powerful AI so much faster and more efficient.
So there you have it. From learning with a teacher to these amazing self-supervised breakthroughs, that's the AI learning ladder. The really big takeaway here is that machines are shifting from needing constant human guidance to being able to teach themselves. And that leaves us with a pretty fascinating question to chew on. As they get better and better at learning on their own, what are we going to ask them to learn next?